Hello everyone and welcome back to another video. So today we'll be solving vertical order traversal of a binary tree. I know it sounds scary and it is little complicated program, but if you really try to understand what is it that we are doing, it becomes very simple. And I want to point out few important points here that before watching this video, make sure you know how BFS works and also make sure you are comfortable with Java 8. So that are two prerequisites to this video. I I would have I wouldn't have done this video before doing BFS and DFS, but because it came in our August lead coding challenge, so I had to do it. So anyway, let's try to understand it. I'll try to somewhat of superficially, at least superficially, I will try to explain BFS, and let's see what's our actual problem is. So given a binary tree, return vertical order traversal of its nodes value. Okay, so ignore this statement because it is confusing. I know when first time I read it, I was like, what does it mean? Okay, so let's try to understand what does it mean. For each node at position x comma y, its left and right children respectively will be at positions x minus 1, y minus 1 and x plus 1, y minus 1. And running a vertical. Okay, so you know what, we can just ignore everything. I'll just explain you through this example. Okay, so here we have a graph, we have a binary tree which has 3 at its root. So its our coordinate of a root will be 0 0. It will start from 0 0, and then it's extremely easy. Whenever we move left, so we decrement our x-axis. Okay, we decrement our x-axis, like here this told us to x minus 1. That's what it means. We decrement our x-axis value by 1, and whenever we go down we decrement our y-axis value by 1, because that's what happens in a normal number line. If you think of a normal number line, when you go towards left, x or our numbers are in negative, and when you go towards right from origin, our numbers are positive. We add 1 or any unit, okay, in our graph. So that's basically what we are doing. Whenever we are moving left, we are subtracting 1 from our x coordinate, and whenever we are moving right, we are adding 1 in our x coordinate. And because this is a binary tree, we there isn't a node above or root node, and that's why it is called root node. So it will always have 0 0, and will always be moving down. So we will always decrement, we will always decrement the value of y by 1 no matter what, because we are not going up, we are always going down. And they are saying running a vertical line from x is equals to negative infinity to positive infinity. Whenever vertical line touches some nodes, we report the values of nodes from in order from top to bottom, decreasing y coordinates. Okay, so what it means is, let's just say we have a x axis here, we have a x axis here, and now we draw a lines on our x axis. So this is let's just say -1, because we are moving 1 unit to the left from origin. So this will be -1 x coordinate and -1 y coordinate. So when we draw a line here, we will find a node. Its coordinate will be -1 and -1. So is there any another node which has same x coordinate? No. So we add it in our list, and now we have 0 0 3. It has x coordinate 0, and when we go here, our x coordinate increases by 1. So 20 will have 1 comma -1, because y is always decreasing. And when we go here to 15, it will have a negative x coordinate of 0, because when we go here we add 1, and when we go here we subtract 1, because we are going towards left. So it will have x coordinate 0, same as 3. So we will return a list of, we are returning a list of list. So our list of list will contain all these elements of all these elements, okay, on x coordinate. Like will first list or list of list will contain first 9, and then a list of 3 and 15 because they both have same x coordinates, and then a list of 20, there will be just one element with x coordinate 1, and 7 will have x coordinate 2. That's its max x coordinate. So we will just return 7. So our list of list will contain 9, and a list of 3 and 15, a list of just 20, and a list of just 7. So that's simple. I think our problem statement was clear. Now we will just try to solve a problem. Okay, so how are we going to do it? First of all, we are going to use BFS to traverse through our nodes like 1 and then 2, 3, 4, 5, 6, 7, and we will store those values, their coordinates and their values or node values in an hash map. So first of all, let's create a hash map, and if you're confused, just try to watch complete video, and then maybe it will become much more clear for you. And if it's still confusing, you can just rewatch the video, and if it's still confusing, you can just try to code out by yourself, or try to just look at the program, just copy the program and try to understand what it's doing. Sometimes it's really difficult to understand what a certain program is doing, so it might take some time, but I think it's not that hard if you know what is a BFS and breadth first search, that is, and how does it work, also some Java 8 concepts, it becomes extremely easy. Okay, so we are creating a hash map is equals to new hash map, and then our hash map will have hash map dot put or root dot value, okay, or roots value. So our hash map will contain its key as values of our nodes like 1, 2, 3, 4, 5, 6, 7 in this example, and our its value will be an integer array. An integer array will contain coordinates of that particular node, and our root node has value 0 0 because it's at the root, it's like at the origin, you can think of it that way. Okay, it's at the origin, so we will just put 0 0 because our origin, and that's wrong syntax, new int, and that's the right syntax. Okay, so that's how we do it. And now we will create a queue of tree node is equals to new linked list. Now we are creating new linked list because our queue is an interface in Java, it's not a class, so we can't create its object. That's why we are using its implementation, one of its implementation, that is linked list in our Java. And yeah, and we basically that we use queue for our BFS algorithm. So if you know BFS, you know why I am using a queue. It makes sense. Now we will add our root. So basically this BFS algorithm, which is a part of our current problem, is helping us to traverse through all the nodes in our graph binary tree. So our binary tree will have like 1, 2, 3. So we will traverse, like if when we are using BFS, first we will traverse level 1 breadth. Okay, breadth first search, so it's in the name, its meaning lies in the name if you think about it. So we will first go to 1, and then we will add 2, 3, and then we will add 4, 5, 6, 7 our nodes and their values in our hash map. So we are using breadth first search for adding all the values into our hash map. Sorry, why now we'll start a while loop while our queue is not empty. Our tree node our current node will be queue dot poll, and now coordinates will have an array of coordinates is equals to or hash map dot get node dot val, because we stored values as key, so we will get its coordinates. And then what we will do is we will just check if our node dot left is not equal to null, and if it's not null, sorry for that, if it's not null, we'll create an integer array called left coordinate left coordinates is equals to new int of 2, because x and y coordinate, and left coordinates of 0 is equals to coordinates of 0 minus 1, because we are moving left, so we will decrement its value by 1. That should be obvious. And now left coordinates of 1, control C, left coordinates of 1 is equals to coordinates of 0 minus, it means the when we are using this coordinates array, these are the coordinates of our element or its parent node. So whatever our left node might be, these coordinates are our coordinates of parent node. So now as we know, our y will be always decreasing, so it will be always coordinates of 1 minus 1, it will be always in negative. Okay, and we are not done yet in this loop. Now we will add q dot add or left node dot left, and we will then do hash map dot put node dot left dot val, because remember we are not, or hash map does not store keys of type tree node, it stores their value, and that's what we need. We don't necessarily need to store tree nodes, we can just use their values. And we will store left coordinates, so we are just storing our left node and its coordinates in our hash map. And now we will do the same thing for right coordinates, so let's just copy paste it and basically just replace right everywhere you see left. So we can just make this right, and we can just make this right as well. Right coordinates is equals to coordinates of 0. So here what we will be doing is, since we are moving in right, we will, instead of decrementing, we will just increment our value. So that's why it will be coordinates plus 1, not 0. Oh sorry, it will be minus 1, and here it will be coordinates plus 1. And then we will just add right, and here as well right, and here right coordinates. So I hope it's not that difficult, because if you think about it, we are just using our basic BFS algorithm. And if even if you don't know what BFS is, I told you what we are exactly doing here. We are just traversing our tree, binary tree. First we are going 1 and then it's left and right, 2 and 3, and then we just whenever we pop a certain element pole, that is means remove an element, we will just get its value and we will store its left coordinates value node in our queue and those. Okay, and then what we'll do is we will just get its coordinates and store them into hash map, and then we will have another if condition and we will do same for it. And when we pop this, we will just do the same for its left and right. When we pop this, we will do the same for its left and right. So basically we are just, you can think of it like a different floors, and we are traversing through our tree like first floor, second floor, or even all the elements on the last floor, something similar to that. This is not a video dedicated to BFS, so I'm not going in too much of a depth, but I think you get the idea. It's not that difficult if you think about it. And now we will have our list of list which we have to return, which is our return type. So list of list containing integer. So our list will contain a list of integer is equals to answer new array list. And yeah, and we will have two variables for minimum value and or you can say extreme left and extreme right. So I will name it max left is equals to 0, and integer max right, sorry, max right is equals to 0 as well. And now we will, for integer of temp hashmap dot key set, if hashmap dot get temp of 0. So what we are doing is we are just comparing our values of max right and max left with our values of our x coordinates of all the elements in our hash map. Sorry for that, I don't know what's this. Temp will be our key of 0, so 0 will be our x coordinate, and we will compare it with max right, because remember we have to create list number of list inside our list, that is this internal number of lists which will contain different element list. Like in this particular example it will contain 4 and then 2 and then 1 5 6 and then 3 and 7, like we can see here. So this internal list 4 2 1 5 6 3 and 7. So how we will get that number of lists? For that we have to find maximum left and maximum right, and maximum right would be the greatest value and maximum left would be the smallest value, smallest x coordinate, and small largest y coordinate will be max right and smallest y coordinate would be max left. So our max right will be equal to hashmap dot get temp of 0, and then we have to basically do the same thing. I mean it's nothing, we are just finding a max and min value in our hash map. Okay, maximum and minimum x coordinate. So I think it's extremely easy to understand. Max left, we'll just do max left is equals to, yeah, if it's smaller than our okay, and if yes, and if this value is smaller than our max left we will just change it. So we are just finding minimum and maximum x coordinates, and now it will help us to know how many, the number of internal lists we require, the number of internal lists inside our list. So for integer I is equals to max left, while I is less than or equal to max right, and then I plus plus. We will just do our answer, which is our list of lists which we are going to return. Answer dot add answer.add new array list of integer. Okay, so that's, I think that doesn't require much of explanation. We are just adding some array lists inside our list, and then for integer element in our hash map dot key set, or integer x coordinate would be hashmap.get element of 0. So we are retrieving our x coordinate, and then we will just answer dot get x coordinate minus maximum left dot add element. So this is almost the end of our program, but we have to return answer, and we have to do one more thing. For list of integer sublist in our answer, we have to just sort these elements internally, like we have here 4 2 1 5 6. So we have to return them based on their y coordinates. The element with lowest y coordinate highest y coordinate should be on the top. That means, like here, 1 then 5 and then 6. So we have to sort them accordingly. So for sorting, we are going to use collection dot sort sublist comma a comma b hashmap dot get b of 1, and that is of y coordinate, minus hashmap dot get a of a of 1, that is our y coordinate again, and we are just returning answer. So first let's just see if this works. Okay, as we can see, our solution is accepted, and as I said, there were some errors, and they were purely not syntactical, but they were spelling mistakes. Okay, basically there were some spelling mistakes like this x coordinate or some other mistakes, which you can just read the errors and solve them easily. So they were just spelling mistakes, nothing more. Our logic is perfectly fine. So finally, once again, I would like to explain what did we do here. We created a hash map which will store value of our nodes as its key and their coordinates as our value, and then we used a queue to traverse our entire tree and store the coordinates of all the nodes. And yeah, basically we used our BFS algorithm, breadth first search, and we traversed our whole tree, and then we created a list which we are going to return. Then we created two integer variables, max left and max right. Max left is the minimum value of our x coordinate, and max right is maximum value of our x coordinate. Like for example, in this tree our minimum value would be -2 because 2 will have -1 and 4 will have -2, and maximum value will be +2, that is 7. 7 would have x coordinate 2, +2. So yeah, that's what we are finding here. Max right will be 2 and max left will be -2, and now we will go from -2 to +2 and add 5 array list of integer, which will contain all the nodes with same x coordinate and sorted according to their y coordinates. So here we are just adding all the elements with same x coordinate into arrays, and then here we are sorting them using our y coordinate. That's it. So if you think about it and you know few Java 8 concepts, I think it was clear. Thank you for watching the video. If you got the value out of my video, please like the video, subscribe to my channel and hit the bell icon. We will meet in next video.